All right, so I'll move on and go into the next presentation. So basically, this is going to be covering um, creating bathymetry collections and doing datum conversions for CMS. All right, thanks, Geraldine. So we've got capability of loading all of this data into the interface, and it can come in a lot of different forms. We have XYZ files, points, shape files, other types of ASCII files that can be loaded. We can have coastlines. You can do all kinds of different conversions within the SMS to get everything in order and able to start working and creating the CMS type of grid. So just an overview here in this particular presentation, and then the next one I'll go into a little bit more detail, but they are covering some of the same materials, so bear with me as there will be a little bit of repetition here. So we're able to load in multiple bathymetry data sets from different sources. It could be from NOAA, hydrographic surveys, LIDAR data, channel collections, things like that. And we want to put all of that material, all of those data sets together into one big scatter set so that we can use that to actually say on your CMS grid, this is what we're going to work with as far as your bathymetry. So we need tools to be able to change the datums and make sure that everything lines up correctly and things like that. So we'll be going over that in the next little bit here. So one of the main things that you'll be doing is, I mentioned it earlier, is everything you bring into the SMS, you need to define a projection. So this is just showing both the horizontal projection here on the left and a vertical projection on the right. We have capabilities within SMS to handle lots of different types of projections. For the most part, in the United States, we use state plane or UTM as our projections. And then within that, the state plane has the capability to be working in either feet or meters as far as what is applied to those objects. Eventually, those will have to be converted into metric because that's what CMS works with. And I'll be showing later today and if needed tomorrow morning, how to do those conversions. You not only have to specify the horizontal parts of it, you also have to tell SMS what that vertical projection is as well. For the most part, we're going to be working in a local datum, and if we need to make changes to NAVD88, mean sea level, or some other, then we'll handle that in a little bit different way. But for right now, we're going to be doing vertical in a local datum, and then either feet or meters, depending on what you've loaded. And we'll go into different examples of both of those in just a few minutes. A lot of information that we get from NOAA Tides and Currents. There's a link here at the bottom of the page, but they have lots of information around the United States, coastal areas, and so you might find a page that has information for the area that you want to be working with. One of those things that we do work with are benchmark sheets. And so essentially those are representations of the different datums that were available for that particular location and what the differences are between, say, mean low water, mean sea level, mean high water, NAVD88. All these are related together, and you have to understand which one is above and when to subtract some information because you want to change a data set to a particular datum, or when you want to add. You want to make sure when you go here that you're choosing the right units and epoch for this particular area. So if it shows up in feet, we always want to have everything related to meters. So you can just click that meters, and then it'll change all the information here over to metric. So when we're preparing for the running coastal modeling system, CMS, we need to get a few things together. So we're working with Cartesian or quad tree grids. For the most part now, it's the quad tree. Just going through this list here, CMS model computation is in metric, and depths are positive from 0. So that's for the CMS model. We need our depths to be positive as you go down. However, SMS 13.1 and later are elevation based. So we need to make sure that we are representing everything within the SMS interface as negative up. So that would be, I'm sorry, positive is up. And as you go down, it is negative. It's a little confusing, but in the end, when all the CMS information is written to the file, they change the sign. So CMS gets its information in the proper orientation. But we'll go over this a couple of times so that we can reinforce that switch from SMS 13.0 and earlier, and how it looks like in the interface. So as it says here, the grid is generated based on a single bathymetry. So if you have multiple, you need to merge those together. All right, and so there are different ways of converting the sign or switching the sign from depths to elevations. One of those is going under data transform, and there's an option to switch the sign. I tend not to use this because it's an in-place change, and so you may not remember that you've changed it. I like having things done to where you can actually see the progression and understand, hey, this sign's already been changed. So we'll show another different way of doing that, which is the data calculator. So what we're going to be doing is some of the examples we're showing is for Shark River, which is in New Jersey. It's under the purview of the New York district. And so for this particular case that was done, they had a lot of different condition surveys for channels over 15 years that we were looking at to see how the sediment was moving through time. But in the end, we were using the latest bathymetry from these surveys to interact with the other surveys as well. So in this particular case, we have a horizontal datum of state plane NAD 27, New Jersey in feet. And so when you come in here and load it, you would have to assign that projection of whatever the data that you've gotten from whoever gives it to you. So you'll normally get some metadata that tells you what datums and projections they were using. You would assign that, and I'll go into that in a little while and show you how to do that. This datum relationships, I like to make a chart to see visually how these things line up and get all of the different pieces that may not have been in that benchmark sheet. They may not have told us exactly what the mean sea level to NAVD88 change was, but through all the different information, we'll be able to calculate and see what these changes are for use later on when we're working with these datums. We really need to understand what we're working with. So this is just another example of the channel survey. We're working for this project in mean sea level. It starts out in mean low water. And so we need to convert this datum from mean low water to mean sea level, which means we need to add 2.25 feet in this particular case, and we'll show you how to do that later on. And each one of these will be shown a little bit later in detail. So to do this, we're going to be using the data calculator, which is under the dataset toolbox. You come in here, it comes up, and then you just click data calculator. This shows you whatever's selected in the data tree what's available. And so we'll be working with the Z. And so in this particular case, we select that one. You notice it has a D1 delimiter here, or a name to it. And so we access that in this calculator window. We say, okay, for the D1 object, we're going to multiply that by 0.3048. And this allows us to change from feet to meters. And then we can give it a new name. So in this case, we're taking the feet in mean low water, and we're changing it to meters in mean low water. But we'll be going over a lot of different calculations later on. And so once you do that, it comes back up, and now we've got this new option in the window that has mean low water in meters. And so now at this point, we might want to make a datum conversion. So we're changing this from mean low water in meters to mean sea level in meters. And to do that, we need to take this particular object and subtract 0.686 from it in this particular case. And that's the conversion from mean low water to mean sea level. And so you go through this, you iterate on this several different times with all the different surveys that you have loaded until they all have a common data set that you're going to be using. A couple more examples. We have this channel survey, and we see the conversion is from low water to sea level, 2.25 feet or 686 meters or 0.686. And so it's a little bit different for different ones. We have a multi-beam bathymetry data set. We have LiDAR data set. And then we have data for other areas that we need to fill in. So we normally get that from one of several different sources. One of these is the coastal relief model. You will note that it's a large data set, and basically they've merged a lot of different hydrographic surveys from NOAA all together. And so it's not necessarily as accurate as we would like. And so we tend to use this only in deeper water where we don't have newer data that was specifically collected. We could also get information from a GEPCO or different places. And like I said, it's not going to be accurate for shallow bathymetry, but you can use it to fill in so that you have data everywhere in your domain. One of the extra files we'll be working with is just a digitized shoreline that would somebody send in from, say, AutoCAD or some other package where they have a shoreline defined, and they provided it back to the end user here. It came in state plane in 8083 in feet, and it was the 0.75 meters above mean sea level contour. So we'll be using that a little bit later too. I'll show you about that. And so for shorelines, you can create a line yourself. You can actually get it from different locations through shoreline data set database. Everything, once you're said and done here, when you go to merge these together, need to have the same horizontal and same vertical datum. And so if you have everything set up correctly, then they'll all overlay together here together in the interface. Sometimes you may see one of them hasn't been projected correctly, and so it may be not shown in the display window, or when you frame everything together, it may show up way down here where the rest of it's up in another corner. And that just identifies that, hey, I need to set the projection and make sure that they all line up together when you're getting these things together. Once you have all the data sets together, you can go through and merge those together. So we would go through under scatters, then there's a merge scatter option here, pulls up this window. We'll select everything that we want to merge together, make sure then that we have all the data sets set correctly, and then merge them together. Then we end up with one big data set to use later on. So in the next presentation, I'll show a few more of those steps and actually go through how to set this merge up together. And then once I'm done with that, then we'll go through a demo and actually be working with that data. And hopefully that will show what we need to know for that. So let me quickly switch over to the next presentation. So in this one, we're going to be working with all that bathymetry. And like I said, a lot of this information is repeated. We're using the same data sets. It just goes into a little bit more what the interface looks like as you're performing these steps. And so I've actually printed this out and we'll be following this as I show a demo in just a few minutes. So the first thing when you come in, you open SMS. This is what the window looks like. There's nothing loaded. There's nothing in the screen. There's nothing in the data tree, except they always have an area property under this map data. But as you pull in information, things will start adding in and showing up. So the very first thing that I always do, and I recommend for people to do, is to go under display and set the display projection to be whatever projection you want to use for this CMS model. It has to be metric, so it cannot be in geographic space. It has to be in either state plane or UTM or something else that's rectilinear. So you would go in here and set the display projection, and when it comes in by default, you shows no projection. And you may use a grid if you don't care where it is in space. You might have this set up to be working in meters. But if you're working at a specific site, then you want to make sure that you tell it, hey, I'm working in a specific global projection, and then you tell it where you want. And so what I normally do is I will come in here. Once I choose global, this will come up. Then I just type in the area that I want. So in this place, for this location, I have state plane, New Jersey, meters. And then it filters everything and only shows the ones that you have available. And so there's a bunch of different datum projections shown, but I typically use the one that's just standard NAD 83, and then make sure that you're choosing the one that has meters and not one that has feet if you didn't add this meters line there to it. Once you have that set and you choose it, then you click OK at the bottom, and then you come back, and then you can see that this area here has changed, and you can scroll through this and make sure it has all the right information. And then you need to set your vertical. And we're just, like I said, we're going to keep this as local in meters. Excuse me. And then you click OK, and it comes back to the main screen. So for this webinar, I've got some files, like I said, day one files out there. You should have all 6 of these files. Your subfolder may be named something a little bit differently, but don't worry about that. We'll be showing that in a minute. But we're going to pull in all of these data sets into the SMS. And so what I normally do is I'll have my SMS ready. I'll have a Windows folder. I'll select these all, and then I'll just drag them and drop them into the main display window. And they'll all be loaded at the same time. And so it'll go through each one of these and allow you to select what's the X, what's the Y, what's the Z columns. And so this is what that looks like. So when it first comes in, it doesn't know which is which because it's looking at delimited and you don't have space here chosen. But as soon as I click space and turn it on, then you can see where it is going to get these different columns and be able to separate them correctly. So once you have this, you can go next and then choose how it's going to be brought in. So you can change this from scatter set to other things, but we're working with actually bringing in bathymetry, which comes in as scatter. So we'll leave the scatter set. We can give it a name, but by default, it comes in with the prefix of the file name that you loaded. Excuse me. So each one of these will come in, and the name will be whatever it is here before the dot. You can change that if you want. You can change this tolerance if you'd like. And this is all relative to the units that this is coming in as. So each one of these that is in a, not a curvilinear, but a state plane or UTM type projection, this will be in feet or meters. And this one right here, where it's in lat long, this is actually a degrees tolerance. So you want to define, like I said, which is the X, the Y, or the Z columns, and then click finish. And then it will say, hey, I've got your data, but now you need to tell me what the projection is for that particular data. So as we showed a minute ago, the same screen comes up, and you'll choose for this data what projection it is in. Bear with me for just a second. Very sorry. All right, so you want to make sure that you choose the correct projection for each one of these as they come up. And so, as I mentioned earlier, these files come from different places, and they'll give you a metadata sheet, or they'll give you a little text file or something that tells you, hey, this is the projection. These were the dates it was collected, have different information about that. So for each one of those, you'll have to make sure that you're using the right projection and information. I put all of these together into a table down here, which I'm going to be referring to. And you'll see similar tables on the later screens where I've added in more information as well. But you can see for each one of these, say for this first one, this 0.75 meter contour, that comes in at state plane, New Jersey meters already. So we can just set that projection and we're ready to go. Once you use a certain projection in the SMS, it'll remember it as a favorite or as a recent. And so you should be easier able to select and assign these to the different ones. I think I'll have an example of that in just a few minutes. Once you pull that in, depending on the tolerance that you selected or if you changed it, it may show you, hey, I've got more points that I can't really resolve with that tolerance. So in this case, it tells me, hey, you've got 112,662 duplicate points, and they've been removed. And you don't necessarily know where they were, but they were so close to another point, it was outside or within that tolerance, and so I was able to remove that. Once you get all the data loaded and converted, it will show up in your SMS screen here. If you did something wrong in the projections, then you will see this data won't look all here together. You'll get a zoomed out view, and some of the data will be up in the upper right corner and other parts of it may be in the lower left corner. And this may be because, hey, you defined feet instead of meters or vice versa, something like that. It just shows you, hey, you've got to do something to make sure that all these show up together. If you look, you can see that there's only really two things that I'm able to see here. There's this light blue data set, and what that is basically the selected data set in the data tree, which you can see it's got a color here and it's highlighted. that always shows up as red in the interface by default. And all the other data is connected together and shown as this light blue color for the inactive colors. So you'll see that quite often. As you switch between these, then these will change colors. And so the red is the active one that you're going to be working with. It's just important to know that so that you can make sure you're working with the right data set and providing the right information. Again, this table shows where it came from, the horizontal information, but also the vertical information and that datum conversion. Rather than continuing to look at a chart every time, I just went ahead and added these back into the table so I can have a quick reference and know what to use when I'm going through this conversion later on. So you may see me, going back to this table and looking at it again and again. As I mentioned earlier, there were changes between 13.0 and 13.1. And since 13.1, it's been consistent. But before 13.1 SMS, positive was down into the water. So as you got deeper into the water, your values would get larger and larger. And then when you were on land, it was negative. So the values would get smaller and smaller. That has been reversed in SMS 13.1 and later. And so everything in the water, as it gets deeper, it gets smaller and smaller or larger and larger negative values. And then the land is always positive. And this just allows them to be consistent in the way they handle every model and everything that you've loaded into the interface and not have to take into account special considerations for this model or that model. It just makes it a little bit easier in the long run for everybody. So moving forward, we've got a little bit of information here. I just kind of wrote down for each one of these what kind of changes are needing to be made. And this is just for my own benefit as I'm moving forward. So I can see in the name of this was a feet-based mean low water data set. So we know we need to change that from feet to meters. And we also need to convert the datum from mean low water to mean sea level. A lot of these are the same. So you see that here. This particular one, this field site measurements, were collected in NAVD 88. And so I've got to go down to mean sea level. And so that conversion is negative. So we'll show that as a subtraction layer. And there may be other things that are not needed. So we'll be able to move forward. I'm just mentioning here that it can be confusing when you're working with datums and how the different datums relate to each other and whether or not you need to add values to convert from one datum to another or to subtract values to get from one datum to another. And so this just helps me visualize a little bit more. And so I fully understand what's going on and how to make these changes. So in the dataset calculator, basically what we're going to do here is we're going to convert from feet to meters and then also change from mean low water to mean sea level. I typically do these in separate steps just so that I'll have one of these that says, hey, this is the only in meters, and then I convert from mean sea level or mean low water to mean sea level. So I'll wind up with several different iterations, but you can do everything in one expression, which is shown here. So you can convert this from feet to meters, and then for this meter value, subtract the right amount to convert from mean low water to mean sea level. So it's all up to you. Just make sure you define this name down here correctly so you can follow exactly what you've done. Once you've done each one of these, you'll see that the scatter sets are still all there, but underneath each scatter set, you've got additional data sets attached to those, that placement of points. And so you'll see for this one, we just have the Z, but for this one, we have 3 different data sets. One of those is mean sea level in meters. And so this just allows us to be able to access each one of these when we go to merge. One thing I will mention, and I don't know this will ever change, but for right now, there is still no undo in SMS. And so we recommend that you save quite frequently. And then that's also another reason to do this in steps so that you can back up and fully understand and be able to redo some of these steps if you absolutely need to. So make sure you're saving as you go along. It'll make your life a lot easier. So once you have everything together, we'll go through in just a minute and we'll merge all these data sets together. So you come under scatter, then merge data sets, you'll get this dialog. And in our case, we're going to merge all these together except for the coastal relief model, because as I said, that's the one we want to use as the very, very last resort. And so all of these others we've defined, hey, these are in areas that I know what those values are, and I want to use that particular data set. So we're going to merge all of these together. So you notice all of these are merged or checked except for the coastal relief model. And then you go through and you choose this data set and make sure you're choosing this data set name to be all the same so that you know that the datums for each one of these is consistent. Once you do that, you can give it a name. And then in this case, we're just merging all of the points together. So we're merging all of the scatter points. And then you would just click OK. It'll give you a little bit of a table over here showing what it did. And then it'll add in a new data set into your data tree. Once you have that, then you're able to move on to the next steps. And so our next step is to basically take this newly merged data set and combine it with the coastal relief model so that we have data all in the offshore as well as in the areas of water and this area. So to do that, we're going to make sure that there's a few things that we have to ensure. And so one of those is that this data set has all of these connected triangles. And so only where the points are very close together are the areas that we want to retain. We don't want to keep these triangles. Each one of these has a value based on the 3 points that it connects to. And so these are not desired. So we want to get rid of those. And so there's a couple of different ways to do that. One of those is to go under scatter options, choosing a maximum edge length or a tolerance or some other things. I always choose to select instead of automatically delete. That gives me capability to go back in case something didn't work right. If maybe this 500 was too large or too small, it'll allow me to go back and change that value before I actually do any kind of changes. So let's do that. You click OK. And then once you come under triangles and select long triangles, then it'll select everything that meets that criteria. And you can hit the delete key and remove those. And you see it removed most of them, but there are still some other triangles here that we might want to remove in another way. So one of those other ways is to come in and we'll switch our tool to working with triangles and selecting those triangles. And I've also changed the display so where that these triangles are filled right now. And so what we'll do is we will hold the control key down and then left click a mouse in the outside of that triangle, then click and drag all the way inside. And when you let up the mouse, then it selects everything that arrow covered, and then you can delete that. So that's a quick way to be able to get rid of large areas. And you can hold your shift key down and select multiple areas before you delete also. And then you want to do that until you've removed all of these different triangles outside of the area that you're working with. And the reason we do this is that if there's a triangle out here for this area, because this is going to have highest priority, it's going to use that value instead of the coastal relief model value. But this is an area that doesn't have good coverage, so we want to use this new value. So that's why we want to remove those triangles. You then come under merge scatter sets again. This time leave all of the other ones off and only choose the merged from before, as well as the coastal relief model. You see they're both selected here. But this time, and you'll want to change this value if you need to mean sea level in meters. But instead of merging all of the scatter points, we're coming down here, we're choosing delete lower priority scatter points. And so you'll just check that box. And then once you check that box, then you'll be able to use these tools to move these data sets up and down so that the lower number or the higher on this table will be given higher priority than the ones at the bottom. And so what we want to do is move this merged surveys, because that's the one we want to keep, up above the coastal relief. So as you go through and do that, you'll see that it's moving up the list from 7 to 4. Once you have that, then you're able to say, okay, when I merge these together, this will be given priority. Then everywhere else we'll use these values, give it a new name, click OK, and you wind up with a display similar to that one, where it's merged everything together, but still kept the areas where we wanted those triangles to provide information, still kept that together. And that's just a zoomed in area for this area. And once you're done, you have all the original data sets, unless you chose to delete them. You've got the previous merge data set and you've got the final merge data set. And so when you finish up, you wind up with something like this. And in this merged, you can see, a few things. You can see the groin fields down here along the shoreline. You can see the actual bay. And you may have other data later that you want to interpolate or to merge in as well. So you'll be repeating this step numerous times throughout your project creation.